Okay. So basically, I did my MSc zoology and MPhil toxicology, PhD also environmental toxicology aspects. Okay. This one. Okay. Thank you. Okay. See, today I want to share some experience related to research aspects and environmental components and also my research projects. Okay. So today, you all know that the environmental consequences and also environmental pollution and very much need about the conservation and also the management. So in this regard, we have joined after completing my MSc, MPhil and also PhD in environmental aspects in 2003 in the Department of Environmental Science, Mysore University, Mysore. So later on, we have concentrated why this pollution consequences is going on. See, I've divided into three aspects. One is what is environmental pollution and management. There are three areas. You all know that nowadays water pollution, soil pollution, and also air pollution. So everyone discussing this water pollution, soil pollution, and also air pollution. There are number of papers came and also publishing. But how to reduce this burden of this air pollutants or water pollutants or in the soil pollutants? This is the biggest demanding and also need of the area. That we will go later, one by one. First, I want to say what is this environment, components of environment and systems of environment and what is environment. Okay. You all know that our Mother Earth, the nature, biological diversity, ecosystem, pollution, its effects, and control methods. See, our natural resources, all this, air, water, soil, on it, number of biological diversity, there are different types of ecosystems. On that ecosystems, we are creating a lot of pressure on ecosystem organisms. Okay. Our Mother Earth, the nature, biological diversity, ecosystem, pollution, its effects, and control measures. These are all which is going to cover today in my presentation. Okay. Just I want to give this small area of this biodiversity. Okay. Flora and fauna of the world and also the country. That's Solpa. Okay. What is the biodiversity? Is equal to flora, fauna, that plants and animals together. Biotic components of an ecosystem. Just first, I want to say what is an ecosystem? What are the components in ecosystem? What may be the different types of ecosystem? Then we will come to the burden of this pollution aspects. Okay. In general ecology, how organisms interact with one another and with their environment. There is an interrelation between biotic and abiotic components in a habitat or in an ecology. So all this, it has a flora, fauna together and with abiotic components. You take water ecosystem or soil ecosystem or terrestrial ecosystem, grassland ecosystem or forest ecosystem, whatever it may be. It is always the interrelationship between the biotic components and abiotic components. Environment, living or non-living components. For example, what is my environment now? It is the immediate surrounding of an animal. What is your environment? Where now you are sitting and also a surrounding of your place is called a immediate surrounding of our place is called a environment. Living or non-living components. We have air, we have temperature, we have humidity, we have the light. All these abiotic components. With that, animal is going to survive it. So that is abiotic and abiotic components together. The interactions taking place in any place, an ecosystem is called as a ecology or ecosystem. Ecological organization, say, you say individual, say population, say community, ecosystem, biospheres. Individual organism in a place, a combination of organisms, the species of the same area, biotic factors. Community, several populations of different species in the same area with biotic and abiotic factors. And ecosystem, the community plus abiotic factors. A biosphere, all ecosystems on earth, forest and marine. You got the point here. How this ecological organization from individual to biosphere, what are the components, what are the population, what are the community, ecosystem, biosphere. And ecology of the individuals. You say homeostasis, balance of an ecosystem, unbalanced ecosystem by many factors is called homeostasis. Balancing biotic and abiotic components with the food chain, with food web in a balanced manner. That ecosystem is, say, homeostasis and the delicate balance. In that components, physiological ecology, temperature and water balance, light and biological cycles, physiological ecology and conservation. If you balance all these biotic and abiotic factors in a delicate level, you can say in a homeostatic condition or balanced ecosystem or balanced habitat, you say. Now, the environmental problems, aquatic environmental issues, if you divide it, water pollution, water diversions, overfishing, and aquatic air quality issues, acid rain, air pollution, nuclear pollution, thermal pollution, light pollution, you can divide it in air. And also climate changes issues, greenhouse effect, greenhouse gases, ozone depletions, and also greenhouse effects. And also terrestrial environmental issues, deforestation, soil pollution, waste disposal, waste burning, mining, etc. And population growth issues. Because of this, habitat destructions, farming practices, fertilizer and pesticides dumping. These are all the environmental problems done by human beings, not other than human beings. You say water pollution, water diversion, or nuclear, thermal, acid rain, greenhouse effect, deforestation, waste disposal, mining, habitat destruction, everything, all done by only homeosapiens, that is this man. So man is the ultimate because of many factors, many needs or many development activities, we are creating all these habitats, all these areas in pollution, that is deteriorating the quality and bringing undesirable changes. Bringing undesirable changes in an ecosystem. Okay. So that is about what is ecosystem, what are the components in ecosystem, how this ecosystem organization taking place, what is homeostasis, how the balanced and unbalanced ecosystem exists if the factors deviates or factors variates. Okay. So that is a basic thing. All you know what is ecosystem, what are the components, what is biotic components in a different ecosystems. You can divide it. You can say that different distinction between environment and ecosystem and types of ecosystems and the components of ecosystem. Now we'll come to the pollution. See, you can give this definition for air pollution or even water pollution or even soil pollution, thermal pollution or mining pollution. This is any undesirable change in the environment caused by human activities. For example, air. Undesirable change in the quality of air in the environment caused by human activities. Undesirable change in the water quality in the water environment caused by human activities. Undesirable changes in the soil quality environment caused by human activities. Yes or no? Are you hearing my voice? Yes?
Yes, sir. Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes. So this broadly classified environmental pollution, say air pollution. In that air pollution, there are different air pollutants. Water pollution, again marine, saline, or usurine. There are many groups in that. I am not going to touch all this in detail. Soil pollution, noise pollution, radioactive pollution, thermal pollution. All the pollution, nothing but undesirable change in the air, undesirable change in the water, undesirable change in the soil, undesirable change in the noise, undesirable in radioactive and also thermal. You put the word undesirable changes in the environment of water, air, soil or noise, even thermal. So environmental pollution classifications. In this, there are a lot of research is going on and there is a lot of divisions are there. And even there is a classification in water pollution, classification in air pollution, classification in noise and everything. I'm not going to touch this. Okay. You know that is pollution in water, air and soil. That I wanted to bring the information to know this pollution aspects in which areas. Okay. Aquatic environmental issues. Even ocean, dead oceans, thermal pollution, that and all. Okay. Then in water, if you say water pollution, just one concept I'm going to touch: water, air, and soil. Okay. Eutrophication. Usually you will call that any water bodies. You can see the water in many places, fresh water. Only 3% of fresh water available, remaining all marine water. Okay. Think about a fresh water. That exploitation of that fresh water, 3%. We are expecting maximum and depleting of that freshwater quality. That all you know, that no need to explain it. In general word, eutrophication in all freshwater bodies. You can also apply in the marine water also this. Eutrophication, the bodies of water becomes enriched with nutrients. This is a problem of marine habitat such as lakes, or it can cause by algal blooms. Runoff from fertilizers into nearby water causing an increase in nutrient levels. It causes phytoplankton to grow and reproduce more rapidly, resulting in algal blooms. Algal blooms are the biological indicators which show the quality of water or deterioration of the water in the fresh water or in marine water. And these blooms of algae disrupts the normal ecosystem functioning and causes many problems in eutrophication. The algae may be used up all the oxygen present in the water and leaving none for the other marine life. So this results in the death of many aquatic organisms such as fish which need oxygen in the water. According to WHO says, at least the permissible limits of this oxygen in the water is 4 mg to 6 mg. So if below that oxygen depletes, automatically all aquatic organisms will die and also it will come out. No oxygen. So the depletion main reason is increasing the eutrophication, nutrient levels and also algal blooms, which depletes the availability of oxygen and which leads below the oxygen over 4 mg per liter in the aquatic system. That is indication of many fishes will die within a span of 20 hours, 24 hours or within a span of even 12 hours. Okay. So these blooms and algal may be block the sunlight from photosynthetic marine plants under the water resources. Some algae even produce toxic components also. Then climate changes issues. Because of this greenhouse effect, the warming that results when the atmosphere traps heat radiating from Earth towards the space. Even ozone depletion, ozone layer deteriorating due to the release of pollution containing with chemicals, that is chlorofluorocarbons. Now there is a statement, the ozone recovery. Okay, so earlier there is ozone depletion, ozone recovery because of the governmental agencies and also policies has taken major steps to releasing these chlorofluorocarbons in the atmosphere. So this I am not going to touch that much. Okay. In the greenhouse effect, you all know this, trapping the solar light and emitted back certain amount of energy and holding that remaining energy within the surface level. So that means it indicates because of many pollutants in the atmosphere, many pollutants in the troposphere. So that may be absorbing this heat and which increase the temperature of this global greenhouse effect. That it leads the some energy reflected back and Earth's surface heated by the sun and radiate the heat back towards the space. And greenhouse gases in the atmosphere trap some of the heat that indicates increasing the temperature in the atmosphere. Why this is happening means because of number of gaseous pollutants, number of particulate matters, number of air pollutants which absorb the heat and which is resulted back. That is why we are facing more heat on the surface level because of this greenhouse effect. Okay. Even in fertilizer and pesticides, you all know that biomagnification, bioaccumulation, bioconcentration. Yes or no? Yes, from producers to consumer, tertiary consumer levels. So all, when you spray the applications of these pesticides on the surface or on the crops or on the garden areas, directly or indirectly, which enters through seepage or through leaching or groundwater, from point sources to non-point sources or drainage. So from that, it transferred to the food chain. That is from producers to consumers, primary, secondary, tertiary consumers, and also particularly consumers. So ultimately, this food chain, the accumulation of these components or metals or whatever it may be, increasing from producers to consumers and carnivores. So that is why the man is in food chain, the man is a high bioconcentrated or biomagnified example, or even the eagle, which feeds one animal to producers to consumers, the concentrating these metals or these compounds or this biotransformation taking place in higher trophic levels when compared to the lower trophic levels. Okay, so this year you will get all bioaccumulation, bioconcentration, biomagnification by dumping of more fertilizers, synthetic fertilizers, pesticides, and all organic compounds and dumping of this waste materials on the soil surfaces. It enters the food chain, and from producers to consumers and carnivores, it enters and concentrating the higher trophic levels in a larger scale. Okay. Then the energy resources, there is a renewable and non-renewable. That is why government is always initiating. That is why government giving some subsidies. That is why government is concentrating to use renewable energy sources. There is also a major part of conservation, you can say, or control measures also you can give it in. So non-renewable energy sources, which we are exploiting in a large scale, we are depleting the sources of non-renewable energies. Fossil fuels, coal, oil, natural gas, as well as nuclear fuels, which we are exploiting in a larger scale. That means we are using this non-renewable energy resources in a large percentage than renewable energy resources. The technology adopting a technology which is already working in more percentage in non-renewable energy resources, not in renewable energy resources. That is why government always concentrating, go for renewable energy resources, go adopt for renewable energy resources, adopt heat energy, hydropower energy, biomass energy, sun energy or wind energy, wave energy. You stop using the non-renewable energy resources. That is a major agenda from central WHO or even the world is concentrated on renewable energy resources, and less concentration to the non-renewable energy resources. So non-renewable energy, once you use it, you cannot renewable or you cannot produce it in a large scale in all fossil fuels or coal or natural gases. But renewable energy sources, sunlight, you can use it. Wind, you can convert the technology. Hydropower or even biomass can be used again and again, and it can clean the energy sources. So this reduce the non-renewable energy uses, increase the renewable energy sources. There is the government is giving. There are pros and cons for each type of energy. The more economic, we know that, but the government is giving lot of subsidies to install this renewable energy source, stop the non-renewable resources. That is also a major contribution if you adopt it for your natural resources pollutions, whether water, soil, or air. Okay. Now, the man affects his environment through the change of land use and pollution. Man is the only animal, or man is the only person responsible what we are facing in a greenhouse effect, what we are facing in the thermal pollutions, what we are experiencing in the heat, that's all what the activities going on are done by our anthropogenic. You can say that it's anthropogenic activity. So man affects his environment through the change of land use and pollution. Major part of deforestation. At present, you know, Indian population 146 crores, 41 crore. For this, if you calculate the forest area requirement, we need 30% of forest area. As on today, we have only 21% of forest area. For our India, with respect to the land areas, with respect to the population, with respect to the agriculture, we have to conserve the forest area 31%. As on today, we have only 21%. So 10% already deforestation taken place. That much of requirement is there or demand is there to increase the forest area at least by 9% next year. I don't know when we are going to achieve this. Okay. So effects on environment, if you continuously doing this deforestation, effects on environment, atmospheric carbon dioxide concentration increases because we are depleting the forest areas. We are doing deforestation. 10%, as on today, 10% of forest area are required. But because of this effect on environment, atmospheric carbon dioxide concentration increasing. That is a carbon thing. That is why greenhouse carbon dioxide is a greenhouse gas. Methane is a greenhouse gas. Ground level ozone is a greenhouse gas. This carbon dioxide concentration increasing means we need more forest area to reduce this carbon dioxide concentration. Soil erosion by heavy rain or strong wind. No root to hold the soil particles together. Soil being washed into the rivers, which fills up the riverbed and it causes the flood. So soil is being washed out into the rivers because no root holding capacity. That means no forest areas, and it fills up the riverbed, accumulates the soil, and it also causes more flooding. Destroy the natural habitats, causes of species, loss of species, cause extinction of species because of destruction of natural habitat. There are a number of species that are going to be extinct or endangered, near to endangered, critically conserved, according to IUCN, and loss of important medicinal plants, medicines, and monoculture, which also affects on the environment. Because increasing the pest population, if you do the monoculture in the forest area, monoculture enables the pest to have a continual supply of food and exhaustion of particular type of minerals. The same type of plants draws particular types of mineral from the soil for a long time. Okay. That is effects of environment by human or by anthropogenic pressure. What is the pollutants? Difference between pollution and pollutant. Okay. Smoke and exhaust fumes are the pollutants. Domestic wastes, agriculture waste, industrial waste, noise pollution. All these pollutants, effect on pollutants on human health and the environment. These are all, I'm going to say just one point. Next, I'll go into the research area of my research. What we have. Smoke and exhaust, all engines, all automobile engines, which always emits smoke and exhaust fumes. That means increasing the carbon monoxide. If carbon monoxide concentration increases, the carboxyhemoglobin permeability with the hemoglobin in blood, which reduces the oxygen carrying capacity of the blood. And health effects shows slow responses, fainting, and even leads if carbon monoxide level is more, which leads to death also. You experience this. If less of oxygen, more in carbon monoxide, it leads to death also because it converts carboxyhemoglobin. Carboxyhemoglobin, after entering into the carbon monoxide into it, it replaces the oxygen. Carbon dioxide is a major greenhouse gas, which accounts for the greenhouse effect and causes melting of polar ice, which increases the sea level and also it causes the flooding of cities, because if it increase the sea level and carbon particles, environmental effects cover the plants. No, it reduces the photosynthesis and make them unable to carry out the gaseous exchange and photosynthesis. So all these carbon particles deposits on the surface, upper surface or lower surface of the leaf. So this is the factory of photosynthesis, the leaf, which all these carbon particles deposit on the surface. No stomatal, no photosynthesis take place on that. You may experience this dust accumulation, all urban area, urban sites of the plants, leaf of the plants. And health effects which cause respiratory diseases. Lead from cars. Health effects affect the mental development of the baby, child, causes headache, irritating, panting, etc. And this is acid rain formations. See how this acid rain forms. All industries responsible for releasing the sulfur dioxide and also NOx, SOx and NOx. So SOx combines with humidity, water to form a hydrogen sulfide, and this forms is the acid rain because of its combination with sulfur dioxide and humidity or water to form a acid rain which falls on the during rainy season. This falling from the surface on the plants, that leaching, it leads die of aquatic animals and also acid leaching. Best example, many places acid rain falls, and even Taj Mahal is the best example, leaching taking place on the surface of the marble because of this rainfall. There is acid rainfall which contains sulfur dioxide and also the humidity and even NOx. NOx and SOx is a major source to form a acid rain in many places. Sulfur dioxide and nitrogen dioxide, environmental effect produce acid rain, which is corrosive to buildings and also plants, and fish are unable to survive in acid conditions. There are number of fishes is going to threat because of this acid rain water. Smog formation. The pollutants trapped by a layer of warm air above so that it cannot rise or disperse. A mixture of poisonous gases and also fog. Fog is nothing but a combination of smoke and particulate matters. And health effects which irritates eyes and also lung. Environmental effects toxic to the plants, and CFC chlorofluorocarbons reduces the amount of ozone in the atmosphere. Health which increases the chances of skin cancer, also this fluorocarbons. Even in domestic waste, we are dumping lot of urban waste in unplanned way in all urban areas. Actually, all this domestic waste, by adopting a sanitary landfill or landfill process, by controlling all leachate control methods. But now, one or two in some places, but all this domestic urban waste dumping in the open way and also without covering any material, without segregation, without proper transportation, without proper controlling measures, scientific methods, that dumping in many places you can observe like a mountains, this domestic waste or urban waste dumping in all in and around urban areas. So environmental effects gives a bad smell and attracts number of pests, and also it's a place for breeding of many animals in that places. And metal cans and plastics, environmental effects, non-biodegradable these are, which needs plenty of space for landfilling. And detergents, which we are using in a large scale for all the purpose in detergents in the household detergents in the laboratories, detergents in the school buildings. We are converting this potable water, fresh water into number of effluents into the water system. Create foam on surfaces, decrease oxygen content in the rivers. Living organisms suffocate. Sometimes many animals will die because of this unscientific dumping of urban waste in urban areas. Increasing phosphate ions cause algal blooms, retites, affect the functioning of sewage treatment plant by killing microorganisms, which the treatment depends. Even in agriculture waste, inorganic fertilizers we are dumping, all synthetic fertilizers we are using for the crops, which leads the effect of environment cause rapid growth of algal. That is called the red tides of the corrective. Use up of oxygen in the water. Fish and other organisms die from suffocation using these inorganic pesticides on agriculture field. Manure. This also decomposes, increases rapidly due to the sufficient food supply. Oxygen content in the water is also decreases. Cause suffocation in the fishes and other organisms in the water. Industrial waste. Soluble poisons, heavy metal elements. Environmental effect. Accumulate along the food chain and cause death when the high concentration, increase the high concentration. Why we need the conservation? So all knowing this, in all areas. For example, you take a water, fresh water or marine water, you take a soil, yes, or you take a air. Which you see the statistics from Pollution Control Board, or you see the publication from any other journals, or you refer the number of articles. So every day, every time in science and technology, the water quality deteriorates in places, bioaccumulation taking place, bio concentration is increasing, or air quality is deteriorating, and air quality in Delhi is very suffocation. Air quality in Bangalore in summer sometimes. This is all areas where due to this all anthropogenic activities. Why we need the conservation? If continuously is going like this, definitely one day or the other we have to face number of consequences in the future. See, sustainable development is not existing. Wherever you take any area, any division, all it is unsustainable. Sustainable development means we should conserve. We use the minimum level of this natural resources and protect it in a maximum level for future generation. Where it is existing, that sustainable development. Nowadays, is there any sustainable development in the water or air or even in the soil, sustainable conservation or sustainable development? No. The rapid growth of population has led to increase in demand for land, thus destruction of natural habitat. Yeah, population is a big episode. Population is increasing rapidly. Increasing that population, increasing the demand also. When to meet the demand, we have to do number of developments. One side is industrialization, one side mining, one side urbanization, another side is vehicular, automobile industry. Every area is increasing. To meet that burden or to meet that demand, of this population. How to check this? How to minimize it is the biggest task in a government level or in NGO level or in a world level or you take in a WHO World Health Organization. Not only our country, all other countries also thinking about this, how to reduce our carbon dioxide, how to reduce our greenhouse gases, how to conserve our biodiversity, how to plan to reduction of this automobile emissions. Though it is a population increasing, government is taking a lot of steps, measures, but adopting and taking action, it depends on the individuals or depends on the particular area to conserve it. Okay. Why we need conservation? Because growing the population, at least if you should think that in a minimum level, if you contribute something to the society, to the environment, at least you can minimize 1 or 2%. Conservation. Why is use of natural resources? Least disturbance to the environment and give good quality of life to man. Use natural resources very less. Least disturbance on the environment. Give good quality of life to man. This we have to think it, we have to focus it, we have to concentrate it. This is the required areas. Everyone should think this, how to. For example, biodiversity conservation, there are many divisions, or executive conservation, institute conservation, even in institute national parks, so sanctuary, reserve forests, protected areas, biosphere, and executive conservation, zoological, botanical gardens, and seed bank, etc. In spite of doing all this, but burden is and difficulties and pollution is continuing. Ways of conservation, recycling of used materials, recycle the paper or aluminum cans, economic use of natural resources, develop other energy sources like solar energy and nuclear energy, that which I showed, that is a renewable resources. Control the pollution. What we should do? Control the pollution. Content of lead and sulfur in petrol. Install catalytic converters in motor cars. Sewage treatment plants properly adopt the treatment of sewage water from urban sites. Sedimentation, shut down the solid substances from such deposition, decomposition, aerobic decomposition, anaerobic decomposition. Okay, microorganisms in the aeration tank by bubbling air in order to oxidize organic components, which facilitate growing more organisms to consume it. Even sewage treatment, fermentation, microorganisms in the digester to carry out the anaerobic digestion in the absence of oxygen to convert this into organic product, produce methane, and can be used as a fuel to drive the sewage treatment plants. There are now ways of conservation. Legislation, law, legal, control the amount of pollutants which discharge. Legislation should be more effective, or legislation come to the action plan. Education, give the awareness. This must the all other scientific developments, technology development, urbanization, transportation is increasing, but no one is giving more importance how to protect our natural resources and also the environmental consequences, what to do, what not to do. That education which required by mass media and even birth control is also to decrease the birth. Everyday solutions: conserve, increase efficiency, reuse, reduce, refuse, recycle. This concept always we are teaching in environmental science students in the classroom, but not practically applying in the all other society to how to reduce or recycle or refuse or reduce away. And more emphasis on research and global pollution. Okay. So what so far we discussed? I have touched pollution aspects of different divisions of pollution, different components in pollution, and different factors. And all this responsible for man to creating this environmental burden. But what is my contribution in the science after taking this environmental science? That is my point now. So the and all, a general information, everyone can read it. You will get it lot of information on such. What is, as a science, as a scientist, as a environmentalist, or as a professor in the Department of Environmental Science, what is my contribution that I want to say? What I explained, they're all general information. Everyone who knows it, you can, everyone thinking this, okay, water pollution, air pollution, soil pollution, no water quality, the no air, proper air, or even soil, what the food we are taking, not 100% pure. Every time you will think this, okay, what the air is we are taking is not good, what the water we are drinking is not good, and what the soil production, the organic, what the products you are producing from soil, agriculture products is also quality is deteriorating. That we are eating, that we have no other options. But taking all aspects, I cannot solve the science. I cannot do all this in research. I can select at least one or two to show my research area or my observations and to submit to the DSC or DBT or other. I was telling you, I am teaching these all aspects, water pollution, no air pollution, no soil pollution. But what is my research part? That this is the, so my main research area is air quality analysis, characterization of air components, yes, and classification of this air component, air pollutants, and how these air pollutants impact on human beings by using animal models. Now, at present, we are running 3 projects. One project sponsored by Department of Science and Technology with respect to air pollution components, characterization and analysis. And another part is how these plants are capable of absorbing this gaseous pollutant. And the third area of my research is how this plant's potential, which type of plant is more potential to reduce which type of gaseous pollutant. This is my 3 research area aspects I want to say. All that come to the totally, now it is on air pollution research area, which I have done in the doing and also done for the last 15 years on this area that I am going to say now. Okay. So previous all that ecosystem, so types, so different classification. This is exactly my research area, which I have selected on air pollution. On that, what I am doing it for last 15 years. Okay. And even my research in US PDF, based on this air pollutant aspects, I got the Raman Fellowship to work in USA to characterize and to study the impact of this air pollutants on respiratory system. So based on that, I got number of projects and I am doing it. Now totally on air pollution aspects, I'm telling my research area. The air pollutant contributions, see, industrial sector 51%. Okay. And manufacturing and construction 13%. Energy industries 31%. The percentage wise, which we are contributing our natural air sources, air pollutants. Air pollution is not a new thing. Way back it was started. When you burn the biomass, it is air pollution. When you cook the food by using biomass, by using wood coal, it is air pollution. The air pollution started way back in 400 BC. For example, air pollution in the earth originated when the man started using firewood for cooking and heating purposes. Hippocrates, 4000 BC, is the father of medicine. For his 80 written medical works, he had written about air pollution prevailing even those ancient times. Edward I, 1200 AD, ordered the first anti-pollution law in the 2073 to restrict the people from using coal for domestic heating. In the year 1300, another law was enacted in London, banning the use of coal and prescribing capital punishment for defense of this law. So that means air pollution is not a new, it was started long back, but the level of air pollution is new. Level of concentration of air pollution is new. What are the major sources of air pollutants? Major sources of air pollution: natural, unnatural. Forest fires, pollen, dust, volcanic eruptions, volcanoes. These are the major natural source. No one can protect it. No one can control it. Naturally, not that much of, but bothering about unnatural sources. In natural sources, not that much of significant. It may be some places, or it's not a significant level, it's not a countable level. But countable level is these unnatural sources. Motor vehicle exhaust, heat and power generation facility, industrial process, auto manufacturing, fertilizer plants, building demolitions. You all know this. London smog and Los Angeles smogs. Due to accumulation of fog, combination of fog and smoke to form a smog. Because of in London, 1952, say that is a third of the London particular wage time of tribes. London smog caused the death of 4,000 people in 1952. It is a combination of smoke and smog and sulfur dioxide, which accumulates nearly about 15 days continuously. So it leads to death. In December 1984, you all know that methyl isocyanate in the Bhopal gas tragedy. The world's worst industrial disaster, Union Carbide was. That is the environment, Mr. Jairam Ramesh is still alive. So Union Carbide India Limited, the pesticide plants in Bhopal gas that was considered nearly about 2010 to be world's worst disaster. So many people still suffering due to leakage of methyl isocyanate. Okay. These are all the standards. National Ambient Air Quality Standards. Sulfur dioxide, oxides of nitrogen, particulate matter, lead. The limits, the Pollution Control Board given the limits. And the concentration by industrial area, residential area, rural area, even ecologically sensitive area. This is the standards fixed in WHO or even the pollution control boards. We should not exceed this much. But now, 70 to 80% increasing this much of concentrations in all the places. Even industrial area, even residential area, ecologically sensitive area, it exceeding the normal limits. It exceeding the permissible limits. And this one is, what are the methods they are going to use to detect the national ambient air quality standards? Even ozone, ammonia, benzene, benzopyrene, arsenic, nickel. The analysis from different devices. The air quality index, to say the range from 0 to 500, a greatest concern. This is the calculation which we are using for air quality monitoring. This is the calculation which we are using to see the pollution level. And this air quality index is, for example, 0 to 50, good, no risk, health effects. 51 to 100, moderate, acceptable quality. Many places. 101 to 150, unhealthy for sensitive groups. Sensitive means children and aged person. A general public not likely to affect. But 151 to 200, unhealthy, all many experience some effects. This is going to face in Delhi. Last 2 months. All this, it exceeds 150 or sometimes 100 to 150 or 170, 180, 200. All metropolitan cities, you are going to see the air quality index more than 100, more than 150, more than sometimes 200 also. This is the world air quality standards in world. You see the color here. See the where is China, India, and many parts of this exceeding the risk. Extreme risk, this color. High risk, this color. And also medium risk, low risk. You see these areas, India, and also China areas, and some parts of this. That indicates extreme. The air quality index in 2007. The world releases new global air pollution data in 2020. See, this is the area where now here it is. First is India, followed by China, followed by Pakistan, followed by Egypt, etc. The air quality status in India, followed by China, followed by Pakistan, Egypt, is a maximum. This report given by WHO, World Health Organization, global pollution levels in the world. See Indian status, see the China and other countries, Egypt, Pakistan. See, this is the 20 worst cities worldwide for air pollution. Among this, annual mean microgram per cubic center PM in cities worldwide. See, many places in India. See, Allahabad, even Raipur, Allahabad, Raipur, Gwalior. Out of air qualities, the last year, the environmental preference index ranked India 174 out of 178 countries for air quality. WHO surveys last year found that 13 of the most polluted 20 cities in the world were India. Out of these 20 cities, 13 cities from India. See, PM 2.5, PM 10 average data particulate matter for first week of April. So this is the status of air pollution index. See, 182, Delhi 164, 3, even Bangalore 310, Mumbai 106, Hyderabad 58, Chennai 179. This varies. So that is why WHO survey last year found that 13 of the most polluted 20 cities in the world were India is 13 cities. Yeah. So this is my first project sponsored in the Department of Science and Technology. Influence of particulate matter oxidative potential on respiratory health, sponsored by Department of Science and Technology, Government of India. The scheme is Science and Engineering Education, sanctioned year 2018 to 2022. So this we are working on it. These are the major pollutants. In this project, my task is collecting this particulate matter, PM10 and 2.5, and sulfur dioxide in different areas of the Bangalore area, Bangalore and also Mysore, and characterize this, analyze this, and taking certain amount and exposure to the animal. This is the first project on air pollution. Methodology which I did is, in this project, this is a respirable dust sampler we have in the department. There are two devices in this, PM10 and total suspended particulate matter, which we collect by using this instrument, which is sponsored by Department of Science and Technology in 2018 to 20. So there it is automatically, the automatic sampling 24 hours programmable timer to the automatically set up, and also the control set you can adjust, and it can be record, and also it can collect the bigger SPM bigger than 10 microns in the collected separate sampling bottle under the cyclone separator, and sampling time maximum 28 hours maximum. This device we have used, still we are using to collect this TSPM and PM in many places of Mysore and urban areas. And this is the working, how it works, how this water enters, air enters inside and pass through the filter, and it deposits all this PM10 here and TSPM here. Inside that device, it works like this. So this is the outlook of how it looks like after collecting TSPM. See, in the bottle, borosil bottle, there is a TSPM. If you go for electron microscope, you can see it like this. It is a small dust particle, the size of this microns in electron microscope. Okay, so this is the paper PM10. See, first is a numbered Teflon filter. See, colorless it is, white sheet. After keeping 12 hours in some places, it converts like this. If you keep 1 day in urban suburban stand area, it will convert 1 day like this. That means that much of emissions in city area or urban area when this vehicular movement is high. And like PM 2.5, PM 10, we'll also collect the PM 2.5 using this sampler sponsored by Department of Science and Technology. Continuously, we are collecting the samples and this PM 2.5, one is PM 10 and suspended particulate matter. This is the first project given by Department of Science and Technology. This is PM 2.5 filters, a small filter which accumulates. See, it is the colorless before keeping. After 1 day or 2 days in urban areas, it looks like this. It can. Okay. So even the gaseous pollutants also like this will collect. That is sulfur dioxide, nitrogen, ozone, fluoride also we are doing. Why I told this means, because I am concentrating only on air pollution now, my research. Okay. So now the mechanism of it converts. This also I'll skip because the lack of time. And this mechanism, how the sulfur dioxide forms with sulfur dioxide and water particles, how it sulfur dioxide formation. Even nitrogen oxides, what is the source? Nitrogen and oxygen and oxygen to form a ozone, ground level ozone, it is a ground pollutant. Okay. So this is the first part, investigating the toxic effect of this particulate matter in air pollution from various emission sources on lung injury and insulin resistance mitigation by antioxidant therapy. This we are. Why we are working on it, air pollution? Epidemiological studies estimated. Okay, why I have to take this? According to epidemiological studies, 4.2 million people died due to the exposure of this particulate matter of air pollution in India every year. Epidemiological studies use the mass concentration of PM10 as a variable to derive associations between the exposures. So this continuously we are doing. These are the first project objective. For characterization, exposing this to the animal model, what may be the impact? And we will study the pathological and also the biological and also biochemical studies. Okay, first thing. After that, we have divided 4 sources: mosquito coil, agarbatti, charcoal, cow dung, ambient. These are the continuously using materials in household activities, in puja, or in by heating cow dung or charcoal we are using ambient. This also continuously we are collecting. We are doing this PM sampler and also 2.5, and we are analyzing this. What may be the mosquito coil PM? What may be the agarbatti? What is there in charcoal? What is there in cow dung? That we have done, and ROS also kept it. I'll skip many. I'll go little speed. Okay. Second aspect to this. This is the setup for collection of samples in my laboratory. See, cow dung, instant stick, charcoal, and also mosquito coil. How this react to oxygen will forms. Then DDT assay also we did. Ascorbic acid also we did. These are our results from first project. So this is our schematic representation of immunoassay. The overall goal of this assay to assess the toxic nature of PM, measuring oxygenated lipid in the human serum. Okay, so this we did, we have done and also submitted. In objective 2, little fast time. So this continuously we are working on it. Yes. And after knowing, after submitting, after confirming the concentration, the characterization, and also the impact of the air pollutants on human beings, then what are the measures how to reduce it? So that next project is, after completing all this in 2022, all these assays, all the immunoassays in animal model, all this body biopsy in the animal model. Okay, this we have submitted in 2022, and later on we got it this Center of Excellence and Phytoremediation, sponsored by Vision Group of Science and Technology, Government of Karnataka. Scheme is Innovative Science and Engineering Education. Now it is also how the plants are able, how the plants are potential to reduce these gaseous pollutants and also even particulate. So this project is running now. Okay. So this, is there any potential plants to absorb this? Or is there any potted plants to absorb all these gaseous pollutants? Yes. We have screened it. We are doing this. All these plants are capable for absorbing PM NOx, SOx, and VOC. Okay, this continuously we are seeing nearly 20 individual homemade plants, potted plants we are identified. We are conducting these experiments in the laboratory. These are the plants which are able to absorb number of gases and also pollutants. These are the common plants. The list of indoor plants which will tested in our initial experimentation, and note that we will keep adding more plants during the study period. These are the common identified, and also we are doing on it. And after that, this we got now. Remediation of indoor air pollution on urban homes to improve the air quality using innovative sustainable technology based on the plant wall air filtration. It's sponsored by Indian Council of Medical Research, Government of India, New Delhi. The center is innovative sciences. So that means first area is characterization of air pollutants and the impact of the air pollutants on the respiratory system. Second part is there any plants? Is there any potted plants to identify, to give potentiality to absorb this gaseous plant? Third project is any innovative technology keeping this in homes to reduce certain level of air pollution inside the home or inside the factory or inside the innovative science and technology ICMR which we are doing. So these are the objectives in ICMR project. This we are doing it. We are constructed and also we have started this. This way, indoor air pollution control methods we are continuation. I'll skip all this objective and also the part of the. I will go to the conclusion part of that. Okay, what is the future aim of this or outcome of this? These are all the objective wise. We are doing some long-term exposure to air pollution contributes to the development of respiratory and cardiovascular diseases. Okay, how to reduce the limitations is there. There are a number of limitations. I'll go. There are gaps also. The gaps in knowledge and purpose of the proposed study. Okay. The novel innovation is, our proposed study is novel in several aspects and also high innovative for improving microenvironment, air quality, such as living areas in urban homes. To improve innovative approach in the laboratory to community. My thought is to develop some model in the laboratory and it has to reach to the community in applicable level to reduce this indoor pollutants, indoor gaseous pollutants in the future. Okay. So this overall goal I want to say, approaches. These are the plans. I want to skip this. Yeah, this implementation that everything. Yeah. Yeah. What is the technology that use the plants to clean up the contaminated site is the green technology that uses the plant system for remediation and restoration. And current methods, the current method mainly remove the transport of RCRA, Resource Conservation and Recovery Act, landfill to pump and treat the types of systems. So many sites are large and pollutant is not high, but still violates the standards. This is the mechanism how the plant it works. The different plants has the different potentiality to absorb lead, to absorb cadmium, to absorb copper or nickel. In the future days, recently research the University of Florida have determined that the species fern, a native to the southeast, strongly stores high concentration of arsenic in the fronds and stems more than 200 times than the concentration of the soil. That means the plants are more potential to absorb the metal compounds, to absorb gaseous pollutants. That is my goal of this. Okay. The advantages, I'll say last point. I think more information. Yeah. My point is, much remains to be studied. Phytoremediation in the two projects clearly plays some role in the stabilization and remediation of many contaminated sites. The main factor driving here the implementation of the phytoremediation projects are low cost with significant improvement in the sites, aesthetics, and potential for ecosystem restoration. This is my outcome, expected outcome of phytoremediation after knowing all the gaseous pollutants of characterizations.